Hello, good morning, everybody. My name is Andrew Dunning, and I'm going to present the Geology News segment. I'm a graduate student here at Portland State University, and I've been presenting this news segment for GSOC for about a year now. So let's dive right into it. This is the Geology News for May of 2021. I like to start out these Geology News segments with an overview of earthquakes and volcanoes, since those are two of my favorite subjects. And the biggest event we had in May was a magnitude 6.8 near Ishinomaki, Japan on May 1st. There were no major damage or injuries, and the nuclear power plants were unaffected. There was likewise a magnitude 6.0 in Assam, India, which is a state in India. There was widespread building damage, though no deaths were reported. There were some fairly dramatic pictures and reports of buildings cracking during the earthquake, but apparently there were no major injuries or deaths. Likewise, if over in the United States, it was a pretty quiet month for earthquakes. This is all earthquakes in the United States since our last GSOC meeting above a magnitude 2.5. And there was limited activity in Idaho and Nevada and California. And these are, again, still aftershocks from quakes that occurred in 2019 and 2020. The largest earthquake we had in North America was a magnitude 5.4 in the Blanco fracture zone off Southern Oregon here, and it was followed shortly by a magnitude 5.2 and 5.3, which are sort of hidden behind this blue dot here. And we are continuing the interesting earthquake swarms in Texas and elsewhere in the Midwest, which are related to gas and oil and gas fields extraction. Moving over to volcanoes, we had a rather quiet month for volcanoes compared to some of the other months we've had lately. The eruptions at Kilauea and Fagradalsfjall and elsewhere are continuing. There are 39 ongoing or new eruptions, and La Soufriere Hills volcano, Soufriere Hills is a different volcano. La Soufriere on St. Vincent and the Grenadines has subsided. That eruption is pretty much over, and very little activity or seismicity is detected right now. There have been several large lahars, but no major reports of damage or injuries or deaths have been resulted from those that I've seen. The eruption at Fagradalsfjall sort of got pretty dramatic. Lava fountains reached up to 1,500 feet. This is viewed from downtown Reykjavik in Iceland. So this is quite a contrast to the sort of gentle, slow-moving spatter cones and lava flows that we were seeing up until recently. Those are still going on, and this lava fountain is much smaller than the spatter cone, is much larger in size now. Moving on to some recently published research, it was an interesting month in the geosciences. And my favorite story from this month was this ophiolite in Maryland. Now, I didn't really think about ophiolite complexes happening or being found on the East Coast, but apparently there's quite a few of them. And what an ophiolite complex is the lowermost oceanic crust and the uppermost mantle. These rocks are primarily peridotites and sheeted dikes and serpentines, sort of all jumbled together based on their place of origin. And the Appalachians are one of the oldest mountain ranges in the world, and there are, I believe, 2, 3, or 4 separate mountain building events that are recorded in these mountain ranges. They're very old. These rocks have seen quite a few things, and among those, some of these mountain building events brought oceanic crust to the surface. And while we knew that these were ultramafic ophiolite rocks, we didn't really know why they were there or how they formed. And they were only recently studied for their geochemistry. And this particular study focused on this timing and the petrology. And they found these rocks to be a suprasubduction zone ophiolite. So this means that as the spreading center that once separated the ancient North American continent and the ancient Eurasian and Eurafrican continents, as the Paleo-Atlantic Ocean, I believe it was the Iapetus Sea this time in history. This was about 490 million years ago. When the Paleo-Atlantic Ocean, called the Iapetus Sea, started closing, at the coasts, subduction zones formed, and these ophiolites sort of hold keys to the process about the initiation of subduction zones. And these rocks are very interesting. Another interesting piece of research came out of the astronomy field, and this is estimating the size of Venus's core. And since the thick atmosphere makes direct study of Venus very difficult, these researchers took 15 years of reflecting radar off of Venus's surface to observe how the planet wobbled as it orbits. And they found that the axial tilt cycles about every 29,000 years, and this orbital wobble is related to the core size. And they estimated, therefore, that the Venusian core is about 7,000 miles across, though it's unknown if it's solid or liquid. Another piece of research that has been going around lately has been this glacial lake hazards. Now, people that live in mountainous glaciated regions have been aware of this hazard for quite a long time, but it's something that we here in the Pacific Northwest and throughout the United States, we don't worry too much about, and that is glacial lakes. So as these glaciers retreat, they leave behind a moraine dam. So this picture is taken standing on top of a moraine, and to the left off screen is the sort of the lowest point on this moraine where the dam is. But this lake here, all of these glacial sediments are very unstable, and this lake can burst through those really at any time. So as glaciers retreat, they're meltwater ponds in these lakes that are in inherently unstable positions. And since 1990, the number of moraine dammed lakes across the globe has risen about 50%. And sometimes these moraine dams collapse, creating glacial lake outburst floods. And there are millions of people worldwide at risk of glacial lake outburst floods, primarily in the Andes and in the Himalaya. At least 12,000 people are known to have been killed up to 2016 by these glacial lake outburst floods. So this is a real hazard and a real risk that people face. And ongoing studies in Peru and Nepal have been working on mitigating these risks by draining these lakes or finding ways to stabilize the moraine dams. Moving over to Mars, we might have discovered Martian glaciers. This is outside of the polar ice caps in the mid-latitudes of the southern hemisphere, the Arcadia Planitia region of Mars. And glacial morphologists have mapped numerous features with this sort of sinuous morphology, and they're calling these buried glaciers. And the reason that they're able to back that up is because of the reflectance, temperature, shape, and the heat capacity. Suggests that these are massive buried glaciers. So these are large bodies that our infrared observatories are able to look at, and they are colder during the day and they stay colder at night than the surrounding rock. So they have very good evidence that these are in fact buried glaciers. However, they are not active moving glaciers anymore. This looks a lot like the ice streams that we see in Greenland and Antarctica, but these don't really appear to be flowing anymore because they've sort of ended up on these flat areas of the Martian surface. Moving down to sunny Colombia, this is a piece about tropical biodiversity pre and post the KPG event. So the KPG event is the end of the Cretaceous period and the Chicxulub impact, which killed the dinosaurs, among other things. And these researchers wanted to know how the current tropical biodiversity is different or similar to that of the pre-Chicxulub impact tropical jungle forest. And their plant fossils that they collected from throughout Panama and Colombia showed that Cretaceous jungles were dominated by open canopy forests of pine ferns with a few flowering plants here and there. Whereas today we have a closed canopy jungle dominated by flowering plants and legumes. And this analysis used over 50,000 fossils from across Colombia. So the impact of this research really tells us about how the meteorite impact and the subsequent climate change affected the biodiversity and plant communities that exist in these Central American tropical jungles. There was a major landslide in Canada. This was on April 23rd, and a massive low-angle landslide in Quebec, which flowed into the Great Whale River. This slide is about 1.5 kilometers wide and almost 4 kilometers long. So this is a huge area of ground that has failed, and it kind of liquefied. If you look at it, this is all really thin material. Obviously, it's a thick layer, but the material is not it's not like rocks. It's not like a rock fall. A lot of these trees are actually in situ. They're still standing upright because this clay just liquefied as it washed past. This was a large area of clay soil that failed, and a large earth flow subsequently flowed down into the Great Whale River. There's several Native American First Nations villages downstream, but there's really no threat posed by this landslide until the snow melts later. And many trees are remaining upright in the runny mud and soil landslide. One of the most interesting and perhaps biggest impact papers that came out in the last month was this one from Ackerson and others, and about sort of the initiation of plate tectonics in the world. And they used ancient zircon crystals from 4.3 billion years ago and earlier. And these mostly came from the Jack Hills granites in Australia. And they found that zircon crystals globally enriched in aluminum about 3.6 billion years ago. Could this be related to tectonics? So all of their several hundred, if not thousands, of zircon samples are plotted on this chart here with their uranium age in millions of years and their aluminum concentration in parts per million. And right between this 3.6 billion and sort of 3.25 billion year window, we have a huge spike in aluminum concentrations. So why is this? Well, tectonic plate motion creates an area of shallow melting over a broad area. This is both sort of at the point where the plate is gliding over the mantle, but also in shallow areas like in subduction zones and other areas of crustal melting that occur in plate tectonic environments. And where in the Earth's crust and mantle melting occurs controls what elements are present in that melt, and therefore in the rocks that crystallize from that melt. And these Australian zircons tracked a shift from deep non-tectonic melting over here to shallow tectonic related melting here. And these researchers have determined that this is a probable window for the slow and very long onset of plate tectonics on the planet Earth. So that's very exciting, very interesting research, and I hope to see more coming out of this method and similar related studies. And that's all I have for you for this month, and I'll see you in June. Thank you very much for watching the Geology News.